My name is Niketan Dubaria, and here we are discussing basic electrical engineering. And here in today's video, we are going to start our next and last chapter of basic electrical engineering, and that is electrical installations. So, what we are going to study in electrical installation, as the name indicates, installation. When we install a power system at our home, maybe at various industries, so we need different types of electrical equipments for safety purpose or for any other purpose. As an example, for safety purpose, we use fuse, MCB, MCCB, and many other devices. Same way, we use various types of cable, and for other things we need batteries for some particular application. So these kind of things will be discussed, which is going to be used in various kind of installation in our power system. So let's start our first lecture with the content of chapter number 5. So these are the topics which will be discussed in this chapter. As an example, if we start with the first topic, here that is a component of LT switch gear. LT means low tension, means low voltage switch gear. As an example, here we will discuss fuse, MCB, MCCB, SFU, and ELCB. Next, we will discuss various types of wires and cables. Next, we will discuss the earthing, why we need earthing, various types of earthing over here. Next, we will discuss various safety precautions. Next, we will discuss the various types of battery and terms related to batteries. Next, we will discuss how to calculate our bill, and lastly, we will discuss the power factor, in which we will discuss what is the significance of power. So, high power factor is beneficial or low power factor is beneficial, and how to improve power factor. So these are the topics which will be discussed in this chapter. So, let's start with our first topic, and that is component of LT switch gear, low tension switch gear. And in this particular topic, we are going to discuss these four topics over here: SFU, MCB, ELCB, and MCCB. Now, first of all, what is switch gear or protective device over here? So that is given over here. The apparatus used for switching, controlling, and protecting the electrical circuit and the equipments is known as a switch gear. So basically, these are the devices which is going to be used for a protection purpose or for a switching purpose of some particular electrical equipment, or maybe for electrical system or a circuit. So let's start with the first one, and that is SFU, switch fuse unit. Basically, we know the function of switch and fuse. Switch is used to when we need a portion or electrical element to complete a circuit, or basically in simple way to turn on and turn off the circuit. Same way, what is fuse? That is a protective device in particular application. If current will exceed out of some limit, so to protect that circuit due to overcurrent, we need a fuse, so that will break the circuit and that will protect the circuit or particular element. So here, what is the switch fuse unit? Basically, at this name indicate, it is a combination of switch and fuse. So that's why this is known as a switch fuse unit. We can find out this switch fuse unit nearby our energy meter. So a few points are discussed over, will be discussed over here. First one, it is switch fuse unit. Now it has a one switch and one fuse unit, as we can see over here. Here, this is a switch fuse unit for three-phase system. That's why here we can observe the three fuses, as well as this is a mechanical switches over here. So basically, for each fuse, we can find out the one switch over here. So these are the three switches over here, and this is the handle by which we can turn on and turn off this switch. Now, when we operate the breaker, this switch basically, the contact will get closed through switch, and then supply will pass through the fuse. Basically, we can turn on and turn off the switch, and when we will turn on the switch, the supply will pass through or current will pass through this fuse unit. And in case when current will be exceed out of some particular limit, this fuse will break the circuit to protect that particular system or particular equipment. So this combination of fuse and mechanical switch is basically nothing but a switch fuse unit. Now next, and that is fuse. So fuse is a short piece of wire basically or thin strip which will melt when excessive current flows through that particular wire, means fuse wire. So here we have two diagrams of two fuses over here. We have observed this kind of fuses in various types of circuit. This kind of fuse, which we use at our places, and this is a fuse which we use normally in electronics circuit. And here we have a different types of fuses. First one is a round type fuse. Next one is a kit type fuse. Third one is a cartridge type fuse. Fourth one is a HRC, means high rupturing capacity fuse. Basically, it is indicating that it is having high capacity or higher rating. And last one is a semiconductor fuse unit. So here we will discuss few of them. So first one is a cartridge type fuse. So basically, this is in the round shape, and this is in closed body, where these two parts are basically conducting part, and these are the connected with this thin wire, and this is enclosed body. So basically, this can prevent the short circuit or be accident because of that. So we can put this fuse in the contact which is designed for this fuse. And here we have another type of fuse, kit fuse, which we use normally at our houses or various industries. So basically, here you can use a porcelain body over here. So this is a porcelain body over here, and in this porcelain body, we have arranged two contacts over here. This is the first contact, and this is another contact. And same way, on this enclosure of this fuse, we have again two contacts which will be fit in this two contacts, and this two contacts will be connected with a thin wire which can melt easily at a particular temperature. So when this body will be on this body, so that will provide a connection in between these two contacts, and that will provide the closed circuit. But if there will be an excess current beyond some particular limit, so the fuse wire which is in between these two contacts, that will melt, and that will protect the circuit in which this fuse is provided. So basically, up to now, what we have discussed, based on that, if we discuss the function of fuse, so what actually function of fuse is? So first of all, we provide a fuse in series connection with this given circuit. So if there will be excess current because of any reason, and if we will provide excess current to particular circuit, that can damage that particular circuit or particular equipment. So basically, we want to protect a particular circuit or particular equipment from this overcurrent, and that can be done by this fuse, as excess current will flow through this wire of fuse, and where set a temperature of that fuse on a particular melting point. So when temperature of this melting wire will reach at a certain level, so that will melt this wire, and that will break this circuit. So this is how fuse will protect our circuit. Now next type of fuse, this is the HRC fuse, high rupturing capacity fuse. Here again, this is the enclosed body as we had seen for cartridge fuse. Now basic differences over here, the rating of this switch is going to be very high with compared to other fuses. Again, as rating of this fuse is going to be high, so when this wire will melt, So that can generate a short circuit, or that can create an accident due to sparking. But as we want to reduce that sparking, or we want to avoid that accident, for that what we had done over here, first of all we had arranged a closed body. So here we have a closed body, and in that closed body we had put this fuse element over here through this context. So these are the fuse contacts on both sides over here, and on both end of this fuse is enclosed by this brass end caps. So here on both end we are having these two caps made of brass, and these are the two contacts by which we can provide a connection across this fuse. And this body is filled with a filling powder. So basically what will happen if this fuse wire will melt? So this filling powder will try to extinguish the spark because of the melting of this wire. So as we are reducing the spark, so we are reducing the chances of accident, and that's why we can design this fuse with high rating. So this is a HRC fuse, and last one is a semiconductor fuse. Basically here we are using a semiconducting device to turn off the circuit when excess current will flow through this part. After fuse, we will discuss next protecting device, and that is MCB, and full form of MCB is miniature circuit breaker. Now we can operate MCB in three ways. Here we will start with the first way. Here, when this MCB will be connected in series with a live wire or phase wire. So first method how it will operate. So for that, here we are arranging a bimetallic strip, and with that bimetallic strip we are using a heating resistor. Why we are using a heating resistor over here? We know that when excess current will flow through any circuit, so because of the resistance of that circuit, what will happen? It will increase the temperature of that particular circuit. So basically, what is the indication of high current? That is the high temperature. So basically, we are using the concept of that high temperature to turn off the circuit over here. And for that, we are arrange a bimetallic strip over here, and with that bimetallic strip, a mechanism is connected over here. Here we are connected a contact of a live wire. So basically these contacts are connected with a live circuit. Means here one connection will be connected over here, and the another connection is connected over here. So basically current is going will flow through this path over here, and when this contact will be closed, so that will provide the current to the circuit. But if we open this contact, so that will break the circuit. But how this mechanism will work? So basically current that is going to be in that particular circuit, that will also flow through this heating resistance. If normal current will flow, so temperature of this heating resistance is going to be a normal condition. But let's suppose that if high current will flow, what will happen? Temperature of this resistance is going to be at a higher level. And what will it do? If temperature of this resistance will increase, that will increase the temperature of this bimetallic strip. First of all, what is the bimetallic strip over here? Bimetallic strip, that means the strip which is made of two different material. Here we can observe that here we have two strips along with each other, and as these colors are indicating that they are made of two different material, and as they are made of different material, so basically we will choose that kind of material which is having different expansion rate. Basically if we increase the temperature of these two plates, so when length of this two plate will be increased, but that length or that increment will be different for these two plates. Means length of this green color plate will be increased more with compared to this light color plates. So basically when we will provide the same temperature difference over here, the change in length of these two plates is going to be different one. So by considering that, let's consider if we increase the temperature by increasing the current. So as the current will increase, temperature will increase, And as the temperature of this bimetallic strip will increase, and as I see, the length of this green color strip will increase more with compared to this light color strip. So what will happen? It will bend down this plate, and as this plate will bend down, so what will happen? As this is bending over here, as here we can observe by this diagram, so that will pull out this spring, and as this spring will be pull out, so that will pull out the contact, and as this contact will be pull out, so that will break this circuit. So basically this will break the circuit. So this is the first method how this MCB can be operated for a high current or excessive current. Now, if we discuss the second type of function for MCB, how it will be operated in second way. So for that, this is again same structure with bimetallic element, bimetallic strip element. So as we had discussed previously, when this will be heated, so this will push this contact and that will break the circuit over here. And for another type of operation, where arrange one electromagnet over here through this live path. So this is the wire where load is connected, and this is the line wire from where we are collecting the supply. So basically this path is providing supply from line to load. So basically here we are getting the supply, and from this wire through this electromagnet, means through this coil, we are providing a supply to load over here. And now what is the another arrangement over here? So this bimetallic strap will work when there will be a slow increment in the current, as if there will be sudden increment in current. So if suddenly current will increase, but that cannot increase the temperature suddenly. So as suddenly temperature cannot be increased, so this mechanism cannot be increased when there is a sudden increment in current. So at that time, what to do exactly? And for that, we have arranged an electromagnetic circuit over here. Here, we had arranged an electromagnet. So basically, for that, we had arranged a coil and a metallic portion over here. So when there will be a current through this coil, so that will produce a magnetic field with a particular amount. But if suppose there will be high current, so what will happen? This coil will generate high magnetic field, and if the magnetic field of this coil is going to be very high, so what will happen? Here we have arranged a mechanical contact over here, and that will be connected with a spring over here. So at normal pull, this coil cannot attract or pull this contact, but if the magnetic field will exceed a particular limit, so magnetic field will again exceed some particular limit. So when there will be sudden increment in current, that will increase the that will increase suddenly a magnetic field, that will increase the force which is applied on this contact over here, and at that time this contact will be pull out over here, and as this contact will be pull out over here, so what will happen? We'll arrange a latch over here. So as this contact will be pull out, this latch will be operated, and this will break this closed contact. So that is going to be in open condition. So if there will be sudden increment in current, so at that time this electromagnet will help to break the circuit, and if there will be slow increment in current, and because of that temperature of the particular circuit is increasing slowly, so at that time this type of mechanism will operate, and this will turn off the circuit. And in third way, this is the cut section of general MCB which we generally use at our home. So here you can find out the electromagnet, means this coil, and this heating element is arranged over here. So this is the two contacts, first one and second one. In between this two, this MCB will be connected in between line and the load. And there is also third way by which you can operate the MCB, and that is the manual way. And for that, we had arranged a mechanical switch over here. So by just turning and turn off the switch, you can operate the MCB, and you can turn on or turn off the or electrical circuit. So basically, these are the three ways by which we can operate the MCB manually or automatically. Next, we will discuss the next protecting device, and that is MCCB. What is the full form of MCCB? That is molded case circuit breaker. And here we had a common word circuit breaker. And as we initially discussed, what is circuit breaker? That can break the circuit. Basically, it is a kind of a switch. Now this is the molded case circuit breaker. So function of MCCB is going to be almost same as we had discussed for MCB. But what is the major difference between MCB and MCCB? So that is the ratings. So rating of MCB is very low with compared to MCCB, and as we are providing ratings of MCCB very high, so basically mechanical strength of this MCCB is going to be very high with compared to MCB. So function of MCB and MCCB is going to be almost same, but as I mentioned, rating of MCCB is going to be very high. So that's why the current which is going to be handled by MCCB as well as the power rating of MCCB is going to be very high with compared to MCB. That's why we have to provide the strong design for MCCB, and that's why we are designing this circuit breaker in molded case. So let's observe these points over here. Now, it is a type of electrical protecting device that can be used for a wide range, as I mentioned, of voltage and frequency, both 50 Hz as well as for 60 Hz. The main distinction between the MCCB and MCB are the MCCB can have the rating up to 2500 amperes, as I mentioned. Normally we use MCB nearby 100 to maybe 125 ampere, and here we can use MCCB up to 2500 amperes, and its trip setting are normally adjustable. This is one of the major difference between MCB and MCCB. Again, I am repeating, its trip setting are normally adjustable. So what is the trip setting password? Trip setting means a particular rating of a current at which this MCB or MCCB will be turned off automatically. As we know, normally when we purchase MCB or MCCB for our home, so we purchase for a particular rating of current, as an example for 10 ampere, 15 ampere. What is this rating 10 ampere, 15 ampere? These are the maximum current which will be allowed to flow through that circuit, means MCB. But if this limit will be exceeded by the current of that particular circuit, and at that current, this MCB will turn off that circuit. So these are the rating or trip setting of that particular MCB or maybe MCCB. So here you can adjust this setting, means you can adjust the level of current at which you need to MCCB to be operated. And next, MCCB are much larger, as ratings are larger with compared to MCB. So basically MCCB has three functions: to protect against overload, to provide protection against electrical fault, and basically you can manually turn on or turn off the switch. So these are the three protecting devices. First one we had discussed fuse, next we discussed MCB, and lastly we discussed over here MCCB. And fourth one, that's ELCB, that will be discussed in our next video lecture. So thank you for watching this video. Stay tuned with me.